Hi, my name is Radu Spora. I'm an associate professor at the University of Surrey in the south of England, and my team specializes in flexible and printed electronics, in particular thin film transistors and their applications. One of the essential aspects of our devices is the requirement for making electrode patterns which are very fine and have very fine spacing, things that aren't really possible with a conventional digital printer, but at the same time are very hard to prototype if you're going to lithography or to other patterning techniques. So the sweet spot is there. And besides, the fact that you have a vast range of viscosities allows you to print many materials that perhaps have some conformality and some shapes that we wouldn't be able to print with conventional inkjet printers. At that time, one of the priorities for us was to try and understand how to best design the device, and that required a bit of trial and error while having the right resolution and the right materials for our electrodes. So we thought that the flexibility that the tools allows would be the ideal solution for us. In practice, the Delta printer allows us to create features and device complexity that would only be possible with photolithography conventionally, while at the same time allowing us to change the patterns and the architecture of the device iteratively with very, very little friction. So this was a particularly useful feature for us. Not only that, but the new updates to the software allowed us to be much more productive. I highly recommend the XTPL Delta printer. Because of the viscosity range and the fine features that you can print, that brings a lot of versatility if you're building perhaps interconnect repair or other passives or even active electronics, as is our case.